able to come stage. So I will do my best without her. So today the subject is interaction of cold surges with equatorial waves. There has been several papers about it, and cold surges is a synoptic feature. It's a very important feature for the maritime continent during the northeast monsoon of Vietnam, Malaysia, Thailand, and also during the Indonesian, Australian monsoon. So we are going to, two scientists will present information about these interactions. Mr. Jeong-Yik from Malaysian Met Department. So we will hear him a bit later. And Donaldi Permana. Donaldi will have maybe a shorter practical train session than predicted. So we will have time after Donaldi Permana's talk to have a discussion about the discussion, summary of the discussions we had and what kind of recommendations we could bring to the international community. So we will discuss a draft paper which has been written by Beata, and during the weeks after the closure of the workshop, we intend to write down a document which could be maybe published in a review specialized for forecasters, like weather and forecasting, for example. So we will come again on this. So I will start with the weather briefing. So I will try to show a bit of the cold surge which is occurring in China. Okay, let me start. So sharing my screen. I have several topics to talk about. Open my chat. Okay. Before looking at the traditional charts and satellite images, a few minutes back on this MJO event, we told yesterday that it was we told that what you see on the RMM index seems to be a very robust MJO event, quite strong outside the circle. This is the bomb axis RMM index based on the 22nd of November. As you see, the bomb is predicting a very nice MJO traveling around the world in the coming weeks, well, in the next 30 days. So it seems quite easy to interpret this in terms of impact, especially if you go to if we go to the composite charts from Fadil, you remember? So if we want to stay on the composites, then we would not expect a wet phase before a few weeks 3 with the phase 5. So we are in phase 2 and then phase 3 and phase 4 next week. So we would only expect some above average OLR maybe in week 3, according to this composite. If we go back to the bomb product, if you go down, then you find a nice filtering of the OLR on atmospheric waves and the MJO. And according to the model this is the model from the 2021st. So the filtering products tells us that we are already over Aceh, Malaysia, South China Sea, under the influence. There is a quite strong contribution from the MJO in OLR already now in week 1. So if you see that if you don't go beyond the RMM index, you can have very basic view which is the general composite. But actually, no two MGO events are never exactly similar. Like two ENSO events are never exactly similar. So each one has particularities. And so the message is that you should go beyond the RMM index and try to check, for example, every parameter which is included in the RMM index. On the NCISCS website, Caltrek website, we are used to working with this page home. And if you go to the tab, RMM tab, there are some more information. For example, in MJO, so which is OLR, U850 and U200 on the Wheeler-Hendon, original Wheeler-Hendon EOF, then you can have a look for each variable. So if I correctly interpret these products, because I have never been trained by Caltrek, I understand that the combined index is in phase 2. That's the, if I understand, that's the current, and December is the prediction in purple, November was in blue. So if I understand well, always check if the product is updated. Seems to be updated. So the RMM index is in phase 2, is significant. The U850 is significant. The U200 is quite strong, but the OLR is not significant. So that's why, as a forecaster, if you look at a satellite picture, well, on this workstation, unfortunately, we don't have the Western Indian Ocean. But if you can have it on a certain website or on your workstation, and anyway, you don't see a dry, subsident area over Indonesia. You should, because the RMM index is supposed to be over the Western Indian Ocean or the Indian Ocean because it moves fast. We would expect the maximum of activity to be over the Indian Ocean and some minimum activity over Indonesia, the maritime continent, which is not true because it's quite active over there. Not monstruously active, but it's quite active. So by your eyes, you can see that the situation is not typical classical for a robust MGO. It's not classical. And the index from Caltrek tells you that indeed the OLR variable is not significant. So that shows that it's always more complex. The situation is always not as simple as in a school book, you know, and you need a bit more time to really understand the drivers. Okay, so going back to the satellite pictures. So before we have a look, so this is okay. So this is the infrared pictures. So as you can see, this is the current situation. We still have the main activity over the South China Sea, slowly moving west, but which has not reached Malaysia yet. The prediction is for to cross the Malaysia and North and Southeastern Thailand during the weekend. And then there is quite a bit of activity around, well, mostly over the seas in this morning, around Indonesia and also around Papua. A bit of regional scale, and what didn't we speak about during this workshop? It's the interaction between the waves and the diurnal cycle. So this is more for regional forecasters on their mountainous island, and there have been many papers about this, especially if I found them. Sorry. Yeah, that's not here. I'm trying to find, but yeah. here it is. Maybe we will hear more about it later today, but as a regional forecaster, you need to know more than the large-scale impact. You need to know the local impact, and the local impact is based on this kind of papers. The knowledge is in this kind of papers, which are not only the MGO, but also the equatorial waves, local smaller waves impact on the diurnal cycle. So this would be the subject of another workshop, okay? It's too much in 1 week. So going back to the image, we'd like to give a special greeting to our colleagues in Papua New Guinea who attended every day, although it is a bit later there. So I want to show you a bit of the diurnal cycle of Papua New Guinea, well, the island of New Guinea with Papua and PNG. Whoops, this is the, I'm trying to move it. So this is the last image. So if I go back in time, this is last night, going back a bit. Going back yesterday evening, sorry. Yeah, so that's yesterday afternoon, yesterday evening. You can see the land convection over the island of New Guinea, a bit of isolated convection offshore over the seas. And then when the night comes, you've got the reversal of the convection. The land convection tends to disappear, and the offshore and coastal convection takes the lead. And in the morning, you've got some coastal and offshore. And then now it's the morning, it's noon, and then it's the beginning of afternoon, and then you have the reversal, rapidly thunderstorms over the mountains. So this is a universal process for the very intense diurnal cycle of convection over this region. Okay. So now we are talking about cold surges. So every 5, 7, 10 days over Asian continent, China, Mongolia, Japan, you've got there are some northerly surges with cold fronts which usually are very weak because there's no moisture advected in the baroclinic process over the continent. So you don't see any rain band like you see in Europe. The rain band will be in Japan. So this is the current situation this morning. I will not animate, but you can guess that there is dry air, but actually it's true that you don't find any sign on the satellite picture of any cold front, okay, of any baroclinic gradient, for example. But you can see this nice northerly flow over Japan and Korea with nice lee effects in the lee of Jeju Islands, the von Karman Allays here, and very dry air mass over China. So you can guess from this picture that you have a northerly and cold air advected southward. So for the forecasters, on the same charts that I show every day, the one which is in the folder for senior forecasters, it's the Presig macro. You've got you have the 950 hectopascal wet bulb potential temperature, which will show the cold advection and the gradients, baroclinic gradients, and this parameter is supposed to be quite conservative in time if there is no exchange, heat exchange. So when it arrives over the seas, rapidly you will have a heat release, latent heat release, and so it will change, but it gives you, with a nice color panel, the view of the cold air over China. So the brown is the very cold, and of course the purple is the very, very hot. And it's not only the temperature, it's the wet bulb, so it's the heat and the moisture together. So this is today. Going back to, yeah, this is this morning. So you can see the northerly flow here. And if you zoom in, you can try to find the gradient at 0 UTC, which should be right over southern Japan. And then you find a gradient over southern China here. So you can understand that, for example, Hong Kong is not in the cold air yet. And you can find the northerly wind, but not so strong. That's today, that's tomorrow. So you can see the cold air reaching Hong Kong. So that's day 2. And day 3, that's day 3. So it will provide some sorry, oops. It will provide some northeasterly, strong northeasterly winds with a bit of a northerly component. If we look at yeah, okay. So the forecasters, they really need to see weather charts with winds, isobars, streamlines, temperature fields, wet bulb potential, so that you understand the situation, and then go to an index which summarizes the situation. But if you go to the index before looking at the charts, then you will not understand exactly what's behind. I mean, at least you are really experienced and you are used to this index, then you understand the things only with the index. But I recommend, especially for younger forecasters, to first get experience of the 2D charts, and then you will have a more expertise in what the index means. Okay, so this is the index, cold surge index, designed by BMKG. I guess it is only used by the BMKG forecasters. I guess every national service has its own tool, index. So this is the one from BMKG. So it's interesting because you've got different informations, which goes from the northern part to the southern part, to the near Jakarta, near the Kalimata Strait between Borneo and Sumatra. So it's a kind of Hofmöller in a way, because the cold surge starts in Siberia. So the top information is the Siberian mean sea level pressure. So a few days, like 2 days ago, this is the very, very strong anticyclone linked to the very cold air mass, which took place over Siberia. And then this anticyclone will move south with the cold surge. So you can detect the first signal of the cold surge is detected in Siberia 2 days ago in observation. So on the left is observation, and then on the right it's the ensemble prediction from GEFS, if I don't make mistake. Then the second product is the difference in pressure between Hong Kong and a city not far from Wuhan in central China. So this morning, especially because I've seen the charts before, I understand that the pressure, there is so we are above the blue line, which is the significant line according to BMKG. So this morning, the pressure in central China is much higher than the pressure in Hong Kong, which means the gradient is in between. So there is a gradient, a pressure gradient, which means a temperature gradient between central China and Hong Kong. So the cold air has not reached Hong Kong yet, so maybe we will verify. And that's the forecast. So in the forecast, you guess that, well, the forecast tells you that, okay, this is a temporary, because it's a synoptic feature. The synoptic feature means it lasts just for 1 day or 2 days. And then it becomes non-significant again, which means the pressure field becomes homogenized, not strong anomaly. And then maybe another one there and the third one there. So there is a prediction of these signatures. The third is the temperature in Hong Kong, measured in Hong Kong. So you can see the minimum and maximum. In the last period, you can see that there was a cold surge which gave minimum temperature of like 15 degrees, but it was not a really strong cold surge. It didn't last for long. And then we have like maximum 25 degrees, which is not cold. And the prediction shows, well, a decrease in the minimum temperatures, but not so much a cold wave. A cold wave would mean maximum around 15 degrees and sometimes even 10 degrees, but this will be for January, February, or December, January. So we have already here an indication that the ensemble model, this one, the one which is displayed, does not predict a terrible cold wave and a long-lasting cold wave either. And we won't see that, but if you go and see the extreme forecast index of temperature, there is no signal for southern China, which means this high pressure, and it was a cold wave for northern China, but it will not be a cold wave for southern China. Then we are reaching the South China Sea at 15 degrees north. So 15 degrees north is, where is it? It is between, 15 degrees north is between Vietnam and the Philippines, okay? So then the index will show the northerly component here, which is supposed to be the consequence of the cold surge in Hong Kong or in China and the northerly surge. So the theoretical papers, well, in theory, the cold air is not, well, the sea is very hot anyway. So of course you won't have the same cold temperature over the seas that over China, but then because but you've got the pressure field. There is a kind of adjustment of the pressure field so that the northerly surge in the wind will run faster than the progression of if there was a cold front, the cold front would be slower than the adjustment of the pressure field. So the signal in pressure and in wind would be faster than the temperature itself. So the index is tracking the northerly component in this area. So negative means northerly component, and the blue line means significant. So below the blue line, it would mean, according to the climatology of cold surges investigated by BMKG, it would be a significant northerly surge at 15 degrees north. Okay, and that's the forecast by the model. Actually, there must be a bit of a spurious effect when you go from an observation to a prediction. That's always the problem when you add two different kinds of data. And I guess this is not exactly what will happen. You can see the temperature too, maybe the bias of the model in the local climate, for example. But if you just look at the trend for day 2, 3, 4, 5, there seems to be a significant signal at day 5, for example, which doesn't last more than at day 5. And then this is for Indonesian forecasters. That's the cross-equatorial northerly surge, and also for Singapore forecasters, the cross-equatorial northerly surge, and also Malaysian for the Borneo, Malaysia in Borneo. The same, so positive means southerly component, if I don't make mistake, and negative would be a northerly flow in the Kalimantan Strait between Borneo and Sumatra. So during the real monsoon, the monsoonal flow will be almost every day northerly flow, so it will be negative. Until now, we are still in a southerly component, which means it proves that it's really not the monsoonal flow. And so there might be in the prediction. I'm not used to. I don't know exactly what's the skill of this GEFS product. There seems to be a bit of a negative component, but not a strong one in the coming days. So that's the way Indonesian forecasters. Maybe we can ask them after to add some information about it. Okay. Okay, so I want to show, because of this, we have seen that sorry. You remember in Malaysia, we expected some quite heavy rain at the border between Malaysia and Thailand due to this cyclonic circulation. And you remember that GFS had predicted a very deep low. This morning, the runs are really not so deep. So yesterday it was kind of tropical storm, but now the runs are really not as deep, but still significantly different from the other models. So the convective scheme in GFS seems to really overreact to the convergence and maybe the heat release of the deep convection. So this is something very important for regional forecasters, is to know the biases of the models and to know which model would be could be avoided or trusted. I want to take a bit of time to show on the ECMWF products. You might know this. How do I open this? Yeah. So this is the ensemble forecast for the grid point, which is near Kota Baharu in Malaysia, in Kelantan province, if it's good. So this is the region which will be in the heavy rain due to this cyclonic vorticity. So this is for a local forecaster, regional forecaster. This is after looking at the regional map, the national maps, and then zooming in on the workstation 2D maps. Then you have a synthesis at a local scale, but you need first to understand what are the drivers behind, what's going on, and then you can go there and you have a better interpretation of the product. So this is the 51 member ensemble with for each parameter. If we focus on the rain, you've got the median. The explanation is given below. So the middle line is the median. You've got the 75%, 10%, and the extreme. Sorry, oops, I don't want to make mistake. It's the 1%. So, for example, in Kota Baharu, this is day Friday. It is day 1. So day 2, especially day 2, a bit day 3, and then especially day 2 is most exposed to the median value of the 51 members for 24-hour accumulation of rain is like 50 millimeters. It's the median of the 51 members. And the max is 200 millimeters, which means only one member or 2 members out of the 51, they produce this. It's an ensemble which has a 9-kilometer grid space. Okay, so it's quite good in order to build a lot of rain. So if you see on a 2D chart, or then if you see on this, you have a kind of a image of the movie of which day is the highest probability of heavy rain. This is when the vorticity center crosses Malaysia, because you've got the synoptic convergence and you add coastal and the orographic enhancement. plus the diurnal cycle. So that makes in all the probability of significant event, if not extreme. And then you've got the outlook, so which is a rainy period for weekend and early next week, and maybe later next week, much drier situation. So this is for Malaysia. And then I did it for Bali, for Denpasar. Oops. Where's my... So do you remember the movie, the scenario for NTT, Java NTT Bali, according to the waves? Can you remember that when we looked at the moist envelope of equatorial Rossby waves, we had a scene. Maybe I need to show you again because this is very important. If we go to, let's say, Carl Schreck website, rapidly. So you can select, for example, first precipitable water over Indonesia, select like 3 days. You select equatorial Rossby, for example. Well, because we know already. So you remember this, early this week, southern Indonesia was in a dry phase of equatorial Rossby, and Papua was in between, and PNG was in between, and then late this week and early next week, PNG and all the seas, Suvah Sea, and then to Java, they enter into the moist phase of the equatorial Rossby. So you bring moisture. You bring moisture to a climate which is not very moist at the moment, it's not the wet season. So until last days, you had very limited convection over the islands, over Bali, over Lombok, over Timor, over Java. You had only isolated and also very few night offshore coastal convection also, and also offshore. So it was a dry period. And now you are entering in the medium range, you are entering a moist period. Moister than normal, but the normal is not very moist. Okay, remember always the normal. But you will add some moisture. Then because most of your islands are mountains, you will really, it's easy to make thunderstorm over the mountains if you add moisture. Attention, because if you add a lot of clouds due to the MGO, for example, a large envelope of a lot of cloudiness, like medium layer cloudiness, like altocumulus, it will be the contrary, because then you will have less sunshine and you will have less sea breeze effect and less convection over the mountains. So the moisture is useful, but if you have too many clouds during the day, then you will have less heating of the land and less thunderstorms on top of the mountains. So that's why it's important to check the moisture before the clouds, because OLR are the clouds. So you understand that you bring moisture and then you will have more easily, so more generalized, not very, it's not at a very high level, but you will have more afternoon convection over a mountain and night convection over the coast and a bit offshore. So that's what you expect from your models. Then you will go in your models and you will verify, I checked, but I don't have time, but you will verify that the model produces more rain over the seas at night and over the islands during the day. This is because of the moisture provided, especially the mid-level moisture. Okay, so I'm going back to Bali. So that's why you find this wet signal in Bali for the medium range. So for next week, let's say. Yeah, that's for next week. So you are now in a dry phase. You are entering a wet phase, not extreme. Be careful because the vertical axis for every city, the legend is different. It's not the same values. So the values actually depends on the maximum, the max you can have in the period here. So if you have one day with 200, your vertical scale will be 200. That's a bit annoying. There is some improvement to do on this product, which is already great. So then you have your wet phase and then dry, becoming dry again. You've got the climate. The climate of the model, I forgot to say, is a dashed colors. So you have the median of the climate is like 4 millimeters in Denpasar. And take care that in the ensemble, it's written here, the ensemble length, this product is based on an ensemble, on the grid point, which is ensemble length point at 52-meter altitude. It's not the airport of Denpasar, of course. So this is a raw output from a grid point from the model. Then you can do some model output statistics to have a statistical output of this. If you look at the wind, this is the wind on average in a model climate, which means at Denpasar, the model has a weak wind and turning around during the day, which means which must be land breeze and night land sea breeze and land breeze. So it moves all around, and you can see that in the prediction for today there is a bit more signal in southeasterly winds. So stronger easterly winds for Bali means more clouds on the southern part of the island, like Denpasar, and even more on the slopes of the mountains, with some coastal convergence with the friction and advection from. So that's a signal which helps to trigger rain on the southern part of the island because you've got a southerly flow at 10 meters. And then the temperature is the temperature. You are much above, you are even in like a record high, but of course the variance is not high in the climate, especially the climate of the model. This is the climate of the model. So the model predicts for today 32 degrees, which is much higher than its average, its median. But of course, its median must have a very cool bias. On average, it's maybe much warmer in Denpasar airport than in the grid point of the model. But what you want to see is the anomaly compared to its own climatology. So when it's dry, you have no clouds, no rain, then the max and often the mean is higher if you are at the sea. If you are in the mountains, if you have a drier air mass, you will have cooler nights. Like in Papua, where you have mountains and villages which are in altitude, which can maybe have some frost, light frost, maybe before the global warming. So if you have a dry air mass, you have colder nights in the mountain, but not usually on the coast like Denpasar. And then when you have more rain, then you have a signal of temperature going back not below average, but around average. Why is it? It's because of the climate change. Even when it rains, it's very rare to have below average now, because the climate of the model is 20 years. So in 20 years, you have fewer and fewer below cold anomalies now. Okay, and you have the cloudiness. On top is the cloudiness. Okay, I will quickly stop this. Sorry, I quit this. Okay, yeah. So that's all for me. I wanted to show how to go from a national, large-scale view of the waves to a regional and then a local. You see, it's important to make your movie in the brain first, and then you have more interpretation of the even direct. This product could be, of course, sent to a user, but it's better to accompany, even if you trust the models, even if you don't add anything about expertise of the forecast. Your expertise will bring informative like decision-making words. You can use probabilistic words in your vocabulary to your users, and you can use like weather types, dry period, wet period, and dry period. It's very easy, very simple information, and the user needs some kind of synthesis of, because this product could be really a bit complex to read, but you can translate it into 3 words only, and it's enough for the user sometime. Okay, thank you. If there are questions, chat. Did you know this product from ECMWF? Such products are also available through, I think, the UK Maghreb's ensemble system. So in the region, the maritime continent, who is using this kind of meteograms, ensemble meteograms? Also on the chat, you can answer. In Papua New Guinea, do you use this kind of products? From Maghrebs, maybe? No. Benjamin in Papua New Guinea says no. Okay. I thought, yeah, okay, yeah. I know the New Zealand Met Service, they provide a website for the Pacific Islands, but I'm not sure you belong to this group. And I know there was a kind of Maghreb's meteogram, a probabilistic meteogram. You want to check Port Moresby? We can have a look rapidly in Port Moresby. Port Moresby. Yeah. Oops, I lost it. National capital. Okay, let's see Port Moresby. You should go back to a drier phase, but of course the climate of Port Moresby is very special on the coast, protected by the mountains. So I'm not a specialist of it, and there is not much signal actually. And you see, as I said, there is a small issue in this product, is that because 1 or 2 days have a very high amounts, then the vertical scale removes any variance, it's not easy with the eyes to see any difference from one day to another, but you are in a well, not dry, maybe normally dry period, and it seems to, for next week, to go into a wetter period, but not so much of a risk of extreme, and maybe except 2 days. But I didn't expertise more than this, but this is for Port Moresby. You can have an information for the winds here. So this is very interesting. Once you have checked the 2D charts, then you have a summary of the movie. Okay. North of 50° north, yes, of course, it's valid everywhere, also in the North Cape, yes. Large moisture inflow interaction with waves, does it mean the moisture is the atmospheric rivers? No. I said that the moisture I told about is really linked to the equatorial waves. Whether there is a large proportion of of the contribution, which is due to this equatorial wave. An equatorial wave is seen through cyclonic vorticity or also anticyclonic, and also the moisture field, so moist or dry envelopes, which are not always very symmetric, but which are followed during a period of like 5 days, 3 to 5 days. So the moisture is brought by the equatorial Rossby. I can show you rapidly on Météo France website. Well, I think we saw it already yesterday, but on synoptic maps, for example, wave filter maps. Must not click too fast. 850. Pacific Ocean, 850 wind. Yeah, so you see on the right here, it's that's the dry, so that's the model from the 23rd, so that's yesterday model. That's the dry contribution today, and you have the moist contribution, but which is approaching outside Papua New Guinea from Australia, and then there is a kind of yeah. So Papua New Guinea has not been impacted by this moist. Well, no, but will be the northern part of Papua New Guinea will be affected by there is a contribution from a dry phase of equatorial Rossby, a dry envelope, while there is a moist over Timor and NTT. And if you verify on the total, well, the sum of the waves and the total anomaly, it's not always the same. Yeah, you've got the dry anomaly for most of PNG, especially the northern part of PNG, which is not always the case for the total anomaly. Yeah? So be careful. There is a difference between the sum of the waves and the total of the total anomaly. But you see the moist anomaly over Java, Java Sea, Banda Sea, etc. There is quite a good correlation with the moisture provided by the waves. But of course, it's not always so clear. Okay. Going back to the chat. Okay. Okay. So I think we can have a break now, and then we start at local time 3:15 for our colleague from Malaysia. See you. Okay. 1, 2, 3. Okay. So now we welcome our colleague from Met Malaysia, from Malaysian Met Service, Jeong-Yik. I don't know you personally, but I'm sure that you will tell us that you are very much involved in the transfer of the research science to operations in Malaysia. Up to you.
Okay, thank you. Thank you very much, Thierry. Can you hear me? Let me on my video. Can you hear me?
The sound is not perfect yet.
Let me just on my. No, I can't seem to on my video. But anyway, can I just start my talk? Hello?
No, it's not good. It's not clear.
You can hear me?
We can hear you, but it's not clear.
Oh, okay. I'll try to speak louder. I'll start the talk now. Is that okay? Is that better now?
No.
No? You hang on.
For everyone, we are trying to adjust the small problem of mic.
Hello? Can you hear me now?
Yeah? Can you try?
Hello, can you hear me now?
Oh, yes, now it's good. Perfect.
Hello?
Yes, it's perfect now.
Okay. Yeah. Okay. I'll start my talk. Let me share my screen. Okay. Is it in PowerPoint now? Probably it takes some time. Okay. It's in the PowerPoint now.
Yeah, we see the PowerPoint, not a large screen yet.
Yeah.
Can you put large screen? No. Full screen.
Okay.
Okay.
Okay. Good afternoon, everyone, and good day for those who are not in the Southeast Asia region. So today I will talk about the interaction of wave with cold surges. So what actually motivates us to study about this wave and interaction with the cold surges is in previous study we have seen that the MGO during the wet phase, actually, when they interact with the cold surge, they actually increase there's a significant increase in the rainfall in the region. So that's what actually motivates us to study about the wave and the cold surge. First, I would like to introduce myself. I'm Diong. from Met Malaysia. I've been working in Met Malaysia for 15 years. I think I have met Thierry once in Macau during one of the monsoon workshop, probably that was 10 years ago. Yeah. So the outline of my talk will be, first I will talk a little bit about the cold surge and the wave. Then I will talk about the R1 means the Rossby wave plus the cold surge. This is based on the paper published middle this year. And next, I will talk briefly about the Kelvin wave plus the cold surge and the WMRG wave plus cold surge. Bear in mind that this Kelvin wave cold surge interaction and the WMRG cold surge results are, I just briefly generated, briefly went through this analysis before the talk. So they are not published yet. Okay. So we know that the cold surge, the climatology, it's cold surge, like what Thierry said earlier today. They actually contribute a large fraction of rainfall availability in the Southeast Asian maritime continent. And this cold surge, the winds are all mainly concentrated on the windward side, which shows that this is actually a wind-terrain interaction, and it's quite obvious. We will look at the climatology map shortly. And for the past 4 days, we have heard about all the waves, the equatorial waves, and we know that they actually play an important role in modulating tropical weather on a large scale. So previous study from Ferret et al. In 2019 shows that the rainfall extreme in Southeast Asia are linked to the equatorial wave. So with these two, the cold surge and the equatorial wave, we want to see when these two ingredients are added or when they co-occurs, what do they do to the rainfall? So so the wave, the equatorial wave data that I'm using in this study, it's developed in the University of Reading. This is based on Yang et al. At 2003. This is a dynamical projection. So horizontal wind geopotential height is used to produce the data set, and the data set are produced at each different layer without any information on the precipitation. That means there's, strictly speaking, this is not really a convective couple type of wave. But if there is, when they're coupled, then they are actually couple wave, convective couple. So the waves are confined. The beta planes are confined between 24 south to 24 north, and it produces wave between the zone number from 2 to 40, and the period of 2 to 30 days. This is the data that I'll be using. For the R1, that means the Rossby wave, n equals 1, we will be, to identify that wave activities, we will use vorticity at, we identify that at using the wave vorticity at 8 degrees north, although this method does not really, specific that you need to use 8 degrees. You can use any latitude within that bound. And we want to know, the same method that used by Ferret et al. We want to know when this amplitude, this wave, we identify at this 100 to 105. These 3 longitude band, whether they are, what happened when they become active. The active wave here means that, or in what Sam means Ferret et al. Mentioned, it's the high amplitude wave. So here in the paper, we call it an active wave. wave, they are defined as when they are equal or exceed 1 standard deviation. So before I go to the wave, this is the cold surge climatology. So from these figures, we can see that the wind terrain interaction are pretty obvious. Okay, but what I want to show also is on figure B. You have this distinct north-south parallel dipole where you have very wet over nearer to Borneo and Malaysia, and you have a drier, anomalously dry in the north. And if you look at the this is the wave vortices, the Rossby wave vortices, we can see that you know, the wave organizes itself with the anticyclonic vortices and the cyclonic to the west. I mean, to the west of the cold surge axis, and this is to the east. Okay, so statistically, there are more than 50% of the cold surge. You will see this sort of Rossby wave configurations, and this is roughly consistent with the theory of Lim and Chan, which says that the cold surge is actually mid-latitude forcing that produce the equatorial wave in the equatorial region. So if we look at the all the active wave day, so we will see that actually this you will see this as what Adrian has shown on Tuesday, that you have this rainfall, and bear in mind this rainfall, we do not do any filtering except that we just minus with the seasonal mean. So this is what we have, and we have that this is a cyclonic vorticity. So we have that rainfall in near the center of the vorticities. This is just the active wave days, only meaning to say that there's no cold surge, what do you call that, influence on the wave. So and of course you see the dry in the anticyclonic phase, in the paper what we call anticyclonic phase. And true to what Adrian has said, if you tend to look from when the wave propagates from this 110 to 100, you see that the signal of the precipitation actually shifted. I mean, from the north being higher signal to, you know, when it comes to the 100 to 105, when the wave is identified over here, you have this stronger precipitation signal over the southern hemisphere. Likewise, this is what's happening also in the anticyclonic. Okay, so we look at what is the impact when we add the two ingredients, that means the cold surge and the active wave, Rossby wave on, when we add these two, and what happened on the rainfall. So what we see is that the distribution of the rainfall is modulated by the phase. You can see if you look back at the climatology, and then if you look at the wave, the active wave by just itself. In the cyclonic phase, you can see that the precipitation anomalies are, you know, further north than the anticyclonic phase. And in the anticyclonic phase, the precipitations are generally far south in the north coast of Borneo. And we can see that, I mean, from our studies, we know that during the active cyclonic phase of the Rossby wave, the cold surge tends to last longer, And if we look at this two, the difference in these are the anomalies wind. We see that the winds, the cold surge winds are more zonally compared to the more northerly component of this cold surge. So if you look at the impact on the rainfall intensities, of course, from our studies, the precipitation anomalies are dominated by the changes in intensity rather than the wet days. So what I would like to say is that the intensity of the rainfall along the Borneo coast extend to the South China Sea. In this, let me just put okay. So this is the extent to the South China Sea during the cyclonic phase. And during the anticyclonic, the intensity increase are not as large as what we see during the cyclonic phase. And this suggests that the terrain-induced rainfall, I mean, if you look at the changes here, so this suggests that the terrain-induced rainfall is modified by the large-scale wave dynamics. So the intensity, for instance, the intensity increase in the Peninsular Malaysia during the cyclonic phase, when if we look at the wave that propagates from here to here, so you look, it's dry here, but as the wave propagates into what we call the longitude of the Peninsular Malaysia, so we see that there's a huge increase in the intensity of the rainfall. Likewise, if you look at this, you see actually the drier. I mean, you have lesser intensity. I mean, going into the region as the wave propagates into that. So, so there is a similarity between. I mean, the similarity between this with the climatology suggests that these precipitation are dominated by the changes in intensity, as what I mentioned just now. And of course, we want to look into what happened to the extreme rainfall. We will look into it in terms of the frequency. So, I mean, the frequency changes with respect to the seasonal frequency of extreme rainfall. So what we can see is that the extreme rainfall in general, there's a increase by at least 40% around where the center of the cyclonic phase of the cyclonic vorticities. And in the anticyclonic vorticity, we see there's a decrease around 20% and has a smaller coverage area. But what we can see also here in the Indochina, there's a huge increase, but this could be attributed to the fact that during this time of the year, they are drier, so additional rainfall might be constructed as being exceeding 95 percentile. So this is the extreme rainfall is defined as exceeding 95 percentile. So in the Peninsular Malaysia, you can see that the signal changes from negative anomaly. That means from less to increasing when the positive vorticities, the cyclonic vorticity propagates into. Likewise, for anticyclonic, the frequency remain relatively unchanged, except for a small decrease over the northeastern coast of the Peninsular Malaysia. Okay, so that's about the impact of cold surge with the Rossby wave. So briefly, I just this is what we got from 2021, the observation. This is based on thermographs wave generated by the UK Met Office for our use. So we can see that during this time there's a negative vortices, meaning to say there's anticyclonic. This is what they call the high amplitude wave. So you have this high amplitude wave. That means anticyclonic over the peninsula of Malaysia. And this is from what we got from the PM map. So we can see that this happened during the cold surge, of course. So we can see that it's dry over this region because due to presence or probably because of this anticyclonic vortices. So this is just one of the example of the observation that we collected. So we'll move into the Kelvin wave. What happens when there's a presence of Kelvin wave plus you have the cold surge. So as we know, Kelvin wave is convergence or divergence. So in this case, we identified the wave activities by its divergence. So here I take the divergence at the equator, and because Kelvin waves propagate eastward, so I will take slightly from somewhere before the maritime continent and propagates into the maritime continent. Likewise, the Rossby wave, the active wave are defined when they are equal or exceed 1 standard deviation. So this is just the wave itself without the cold surge. So you can see, I mean, similarly, we do not do any filtering on the precipitation, on the rainfall. Just the anomaly, just minus with the seasonal climatology mean. So we can see that the negative here, because this is divergence, so negative here means there's a convergence. So we see that it's propagating eastward, and when you have that convergence, and likewise when you have that divergence, so it's propagating the drier weather into the maritime continent. So this is what we do when we add for them, when we identify the cold surge, and that coincide with the active wave, like what we call. So roughly this is a 2D. The winds are dominated primarily by the cold surge wind, as you can see. But we can see there's some spatial difference between these two. Of course, with the drier weather, interacting with so it actually modifies the local effect of the cold surge terrain interaction. So what I do is that I take the box plot of all the land rainfall, the land rainfall from chirps over the peninsula Malaysia, which I average, between this latitude and longitude. And what you can see also here, this is the this dashed line here is the percentile, showing that this is the fifth, the 5, 50% and 95 percentile. This is the dash is representing the NDJF rainfall. So NW means that there is no active wave. Okay, of course, we also put that as a convergence or divergence. CSW means there's a cold surge with the active wave, and high wave H wave means there's just the active wave without the cold surge. So what we can see that in Peninsula Malaysia, the cold surge event without, if we look at all these blue box here, even without the active wave, we see there's a high chances of them reaching 95 percentile. I mean, exceeding this 95 percentile threshold. So there's also a chance, increase in chance of extreme rainfall, extreme event when the convergence phase, during this convergence phase, when there is, you have a higher chances of happening when the cold surge plus the active wave during the convergence phase. So similarly, when we add the divergence, when the divergence are in the east, in this, this is the divergence in when the divergence, when the Kelvin wave divergence is in 105, there's a rainfall exceeding 95 percentile, exceeding the 95 percentile of the seasonal rainfall. Okay, so we also note that the amount of rainfall respond according to the divergence convergence that follows and precedes precede the wave convergence in the longitude. So if you look at this, of course, during this, when the active wave is in 85, when this is convergence in a real sense in Peninsular Malaysia, there's a divergence because the wave, the wave that the phase that follows is a divergence. So that's what the message that I'm trying to say here. Then I will also look into what happened. Okay, what happened when in Sumatra? So what happened when the waves are in Sumatra? Similar to what happens in Peninsular Malaysia, the cold surge event without any active wave shows high chances of reaching the 95 percentile threshold. But when the convergence in the Sumatra longitude, when we look at this box plot here, the rain associated with this this category, when cold surge plus the active wave coincide, the 75 percentile of this is almost comparable to the 95 percentile of the seasonal rainfall. So the chances of this exceeding is the highest comparing to others. So likewise, when there's a divergence phase, even when when you have just without any active wave, you see it exceed the 95 percentile, but with the divergence phase happening in this longitude, you see that it does not exceed the 95 percentile at all. Okay, so the next is the westward moving mixed Rossby gravity wave. For this wave, we identify them, the activities at the 10° north or south, but because this is the antisymmetry, so when they are in a convergence phase in the north, you have a divergent phase in the south. So likewise, we use the same the longitudinal band in this region here, and also whatever equal or exceed one centrifugation is flagged as the active wave days. I'll just briefly go through here. So this is what happened without cold surge. So this is convergence, this is divergence. So you see the signals are, the precipitation signals are opposite. Okay. I see there's a questions. Okay. Okay, so this is when we have the call that, when we have that cold surge happening. So we see that the positive and the anomalous positive or negative rainfall is associated with the what do you call that? With the convergence and divergence of the phase. I mean, from what happened to the wind terrain rainfall with addition to the with the WMRG wave. Okay, so I won't go much detail into here, but let me just hang on. Okay, so similarly, like what I did in the previous one on the Kelvin wave, so I did this for the Peninsular Malaysia only. So we can see that the cold surge event itself, without any active wave, actually also have a high chance of exceeding the extreme event. And the highest chance of exceeding seasonal extremes when convergence phase in the in this and hold on, when they are in the 95 to 100, that means when the wave is in the west of Peninsular Malaysia, and when the wave is in the Peninsular Malaysia region. Okay. For the divergence, when the divergent phase of the active wave is located to the east of the PM, I mean here on the PM, on the Peninsular Malaysia longitude, there's a slight increase of chance of exceeding the extreme rainfall threshold, but not when it's located in the Peninsular Malaysia longitude. So although in the divergent phase of the CSW in the longitude, when they are located over the Peninsular Malaysia, there's still some chance of exceeding extreme rainfall event. And this is greatly reduced when compared, even though this, you see, I see it, but this is greatly reduced when you have just the cold surge alone without any divergence over the Peninsular Malaysia. So as a summary, I think it's good enough for 30 minutes. So depending on the phase of the wave, the changes of the extreme rainfall can be linked to the wave. So depending on whether it's a convergence or divergence or anticyclonic or cyclonic phase, so the extreme weather associated with cold surge can be changed. So we show that the R1 vorticity phase modified the local rain when the associated large-scale organized, enhanced or suppressed rain propagates into the region from what we see, whether it's cyclonic phase when they propagate, so it will enhance the local rainfall, and the frequency of the extreme rainfall are largest when they are in the cyclonic phase of the Rossby wave, plus and they coincide with the cold surge. And I will short analysis show that the chance of the extreme rainfall event also increase with the presence of other equatorial wave. They change. There's a change. They change according to the phase, whether it's again divergence or convergence. And this statistical analysis, when we combine the equatorial wave and the cold surge, between the cold surge and the rainfall, the relationship between these the combination of equatorial wave and the rainfall, we can actually combine it with the dynamical forecast to produce this what we call hybrid dynamical statistical forecast for extreme event, which is I think the group in Reading is working for the more graphs. With that, thank you very much. Is there any question?
Thank you very much, Diong.
You hold on, I can't hear you.
Please. So there were two questions in the chat.
Okay.
Do you want me to read, or I let you read maybe about the moisture? Do you mean, is it the moisture, is it intruded or modulated by the presence of the wave? Can you understand? Can you see the question?
Yeah. Can I answer the question on the box plot?
We lost the microphone. We lost you.
What about now?
Yeah. Okay. Okay. Now. Yeah.
Okay. Okay. I didn't understand the categories in your box plots. Please re-explain what is NW, CSW, H wave. Okay. NW means that there is no active wave. That means it's a cold surge, but there's no active wave around. CSW means there's a cold surge plus the active wave. H wave means that there's an active wave, so there's no cold surge. And chirps are the rainfall. I think it's a reanalysis rain, not reanalysis. I think it's a precipitation data set. I have that reference that I can share in the chat shortly. Yeah. So yeah, I hope I answered the questions.
Yes, I think so. And there was another question earlier on the moisture. Is it intruded or modulated by the presence of the wave? Trying to understand.
Oh, okay. Do you mean the moistures are intruded or modulated by the presence of the wave? Is it like the moisture are trapped within the cyclonic circulation that intensified, and the other one being trapped moisture, it fails to intensify? Okay, but these questions no, this is not about whether it's been trapped by the moisture is trapped by wave, but rather that the convergence. I mean, correct me if I'm wrong. The other scientists, when you have that convergence or divergence, or you have that cyclonic vortices or anticyclonic vortices, this actually creates the instability in the atmosphere that actually plus the ingredients, the instabilities by the cold surge, which cause the rainfall changes. I mean the rain, change. That answer your question?
Yes. Answer is yes. Are there any questions? Any other questions? I have some.
Okay, yeah.
First thing is that as a forecaster, we see that the areas of convergence and divergence are very important. And it is a fact that on the operational model charts we have, the divergence field is very, very noisy. So we cannot make any interpretation of because it's very, very noisy. So only the stream function fields, but it is generally not on our workstation. It is on the websites. So stream function is smooth. I know that maybe, so on satellite pictures, maybe on the observation, we would need kind of convergence and divergence fields as you show in your scientific papers. You see what I mean? Just to understand, because that's why it's raining. But in fact, yeah, on an operational basis, I think the forecasters will agree with me. We miss this kind of data. What do you think?
So for this kind of data, we actually, we are actually working with the UK Met Office, and they're actually transferring that the high amplitude wave. I think I've shown here. Hold on.
You see, it was to when we
this is
this kind of chart, very nice.
Yeah, this is this is they are kind enough to use their MOGRAPS data sets, and they have actually produced this for I think for the partners. What we have this WCSP partnership between UK Met Office with BMKG, Malaysia, and Vietnam and Philippines. This is available for the forecaster to use, and they can actually look at this. Is actually it's an anticyclonic, anticyclonic. What do you call that? What is this? Yeah. And likewise for the Kelvin wave and WMRG wave, they also produce similar thing, but instead of vorticities, they produce convergence and divergence. That's what prescribed in the paper by Farad et al.
Okay.
Yeah.
Somebody says that he didn't understand the first point in your summary. Can you show again your summary?
Yes. Sorry, the dogs are. Okay, is this the one?
Yes. So the first paragraph.
Yeah, depending on the phase of the wave, the changes of extreme rainfall associated with the cold surge can be linked to the wave. Meaning to say that so we have shown that like during when you have a anticyclonic wave in peninsular Malaysia, so of course the anticyclonic will be dry, so you will not expect the rain to be extreme even when you have cold surge happening. So this is what I'm trying to say here. So likewise, we have shown, like for instance, like in this picture here, you see this is a convergence of the WMRG wave. You have the cold surge, but the response are different when you have the divergence over here. So you can see the difference in that, what the wave does to the cold surge rainfall on the local, on the wind terrain interaction.
Yeah, you mean you need a certain combination of the wave and the cold surge to produce extreme.
Yeah, that is the basic idea of that paper, actually.
Okay. Thank you. I will have a last question for about the Met service in Met Malaysia. So do the forecasters use a cold surge index, and also do they make use of the waves? Did you manage to bring some science into the room, to the operational
Yes,
room?
for your information, we have, I mean, we have the cold surge index, but the cold surge index is slightly different from what I use in the paper, because the cold surge index we use in Map Malaysia is just based on the meridional wind, or the wind. But in this paper, I included, in addition to the wind, the northerly wind speed, I also included the mean sea level over the Hong Kong region. Simply because in research, we can't actually just rely on the northerly wind, because sometimes you have the cyclone that produced the bogus northerly wind. Yeah, so we use that. So one of the reasons why, I mean, for the forecasters in the Map Malaysia, we're just using that because they can actually just look at the chart, the 2D chart, like what you show, and they can see that, okay, this actually comes from the mainland of China. And of course, using that information plus the information provided by the website actually produced by the Met Office. So yeah, they're actually looking whether is there any significant wave during this period, and then they try to base that forecast with the wave actually. Yeah.
Okay.
So this research is quite new, so they're still trying to adapt or trying to use this method for incorporating into their forecast. Yeah, thank you very much.
Thank you very much.
Okay,
So
thank
it's
you.
already 4 p.m. So next speaker, Donaldi Permana, will have he told us about 30-minute practical session. So we can have like 8-minute break and start at 4:10. And then after Donaldi Permana, we can have a bit of time for discussion before closing. Thank you. See you 4:10. Okay, Donaldi is here. So now I start again. Thank you for staying until the end. If you want, we can continue on Monday. So now we are glad to receive Donaldi Permana from BMKG for the practical session. Can you introduce yourself, maybe, for people outside BMKG? Thank you.
Okay, thank you. So it's my time now, Thierry?
It's okay.
Okay. Okay, so good afternoon, everyone. Let me share my screen. Okay. So thank you for having me here in this workshop. So I'm in the last session of this workshop. I hope you're still in a good condition. And then yeah, I'm in the practical session of the interaction between the cold surges and waves. I think has been discussed by Diong, the previous presenters, that I'll be more focusing on the interaction between the cold surges and the MJO. So first, let me introduce my name. My name is Donaldi Permana. I'm from the Research and Development Center of BMKG. My research are related with the various time scales, starting from the S2S up to the climate projections on climate. So today I'm going to have an interaction of waves with cold surges, but more detail. First, this is gonna be the code that I will use and the data set. I have to set that the data set is large files. It's about like 3.8 gigabytes. I mean, you don't have to do download and run it right now, but you can do that later. I will just show you how it works. I will copy paste this link very soon. Let me share the link. Okay. So this is gonna be my outline. I'm going to try about the cold surge life cycle, about what is the cold surges definition, and the index that usually being used to identify the cold surges, like the previous graph showing by Thierry that has been produced by the BMKG about the temperature difference between Hong Kong and Gushi, and then also the meridional wind average over the 15 knot. And then I will also try to simulate some like cold surges definition as being described by Lim 2017, which also being used by Diong in 2023 paper. And then we'll see that how we can calculate the number of days with the cold surges, number of days with MJO in these cases, and how calculate between if those events occur at the same time, and then to see how that impact on the rainfall anomaly over the region. This is just some resources you can access to this one, or you can also see this slide in my the GitHub that I shared before. So this is just some definition being described in Lim et al. 2017. I think this is also been discussed by Diong previously, basically to identify the cold surges days. We consider these two domains, D1 and D2, and if we fulfill this 4 criteria, this is the average wind speed 850 hectopascal over domain D1. So the zonal wind has to be a calm and easterly wind, and it has to be the northerly wind, which is the V value less than 0. And then the normalized wind speed has to be at least 0.5 standard deviations. And then there is additional criteria, which is the maximum mean sea level in domain 2, at least 1020 hectopascal, which is associated with the high pressure over the northern part. Again, this is just examples. The right one is the northerly cold surges monitoring graph that has been explained by Thierry earlier. We see there is several graphs there, and on the left hand side is this is the monitoring that has been developed by the UK Met Office about the cold surges, the possibility of cold surges, and also the cross equatorial northerly surges, or we call chance. And then yeah, this is basically usually the cold surges was monitored. And again, this is the latest paper by Lubis et al. About how cold surges interaction with the MJO, which is also very interesting to be discussed. I will go with that. Okay, now we going to Jupyter Notebook. I hope you can follow me on this. I will just stop this one. So this is the code that I have. So if you download from here, you will have these 3 files, and then this is the main script, and this is basically the hands-on that I just showed you before. And there is the MJO2 CSV, which basically the RMM index amplitude of the MJO. And you can also download the dataset in this link. And again, it may take some time because it's a big file, but you can try. Okay, we'll go here. So again, first that you have to make sure that you have all the package of the Python package, because we're gonna use the CartoPy, X-Array, and NetCDF4. So if you don't have, you can uncomment this line and then run this line. Okay, since I have already installed that, so I don't have to do this. You can go to the next section here, which basically to import all of the packages. You can just run here, and everything is good. And then this is basically the source that I discussed earlier. This is the cold surge life cycle. First, that there has to be the pressure surge outbreaks over the Siberia Mongolian high here. So for this case, I choose this period, 20 January to 10 February 2007, to see how this kind of cold surge can be monitored. So this is basically the code to extract the mean sea level. This is the domain for the Siberian. So in this case, that I use the OpenDAP link. So basically, this link is you can access the NCEP2 reanalysis data. This is from the ADPRC in the University of Hawaii. And if you go there, you will see something like this. So basically, they provide the reanalysis to be accessed. There is an era 5 and say, but you can see inside there, let's say for era 5, there is a daily data, but not all component there. There is also hourly data, so you can access the data on the fly. So basically this code will download the mean sea level over this area, and then they will calculate the maximum value. And then if you run this part, it will take time sometimes because it will connect to the internet to get the data. And at the end, they will plot something like this. Okay, and this will also have create the file as MSLP. You can see the file over here, which is basically similar with here. So basically here that you see that the blue one, basically on some days it hits the threshold because it said that initiate when the Siberian high above 1045 hectopascal, which is basically this dashed red lines. And then we go to the next stage of the search, which is the arrival of the search. So usually there is an arrival sudden dramatic decrease of temperature over Hong Kong. And usually we use the temperature here. No, first also the mean sea level. Here, the mean sea level difference should be about 10 millibars between the this location, which is in Gushi, China, and Hong Kong. So basically, this is similar. They took the domain, sorry, the value of the mean sea level over Hong Kong, and then different with the Gushi location, and then they will plot the mean sea level difference between Hong Kong and Gushi. And the second one, it will also download the surface temperature because it said that within 12 to 24 hours, there should be like a decrease near surface temperature around 4 or 5 degrees C. So based on that, we also try to extract the value. And if we run this code, it will show you the difference between the mean sea level difference between Gushi, Hong Kong, and also the temperature difference over this area. We see it may take some time because it has to connect with the internet. Yes, so this is how it looks like. So we can see that the mean sea level difference are above 10 in some days. And then this is the 12 hours temperature difference. We can see that in some days here, the temperature difference, which is on the right y-axis here, it's about 4 or 5 degrees C. So this is also one of the indications that the cold surges are happening. The next phase is basically we have to calculate the mean, the average 925 meridional, millibar meridional wind between this and this along the 15 knot. And then from that, we categorize the intensity of the surge, weak, moderate, or strong. So basically, this code is downloaded the V component from the era 5 here, and then it's calculate the average meridional at 15 north. So again, we try to run this code, and this is what we have here, that a lot of days that actually has passed the threshold of even moderate or strong surge. And then there is another possibility is that the surge can cross the equatorial, right? So this is what has been proposed by Hattori in 2011, the chance, which basically you have to calculate the average wind over this area, this box, right? And if it exceeds the 5 meters per second, that we consider that as a chance. So you can run that and then wait for some times, and then you can see that if it's more than 5 millimeters per second, it's considered chance. So this is what we have here. So why this is negative? Because V negative means go southward or northerly. Okay, so from this exercise, we can see that how we can monitor the cold surge, and if the data is forecasting, so we can predict the chance or the cold surge events. Okay, I will just go fast. The next step that I want to discuss is about the interaction between the cold surge and geo. Again, this is based on this paper. Again, there is the 4 category that I presented here before. Let me remind you again. So this is the 4 category, and you have to have like these 2 domain, D2 and D1 and D2 domain. So for this case, I use the MSLV from the NCEP2, winds from the ERA 5, and for the precipitation, I use the CMOP. 9, I think. Okay, so in this part, I just defined the domain 1 and domain 2 here based on the definitions in this paper. And then I used the data from 1998 to 2002, which is about 23 years. So that's why the data is a bit large, because it contains the 23 years daily data of wind and precipitation. And then we use level of 850 according to this definition. Yeah. Okay. So now we run this part. After we run this part, and then here this is just the function of wind, because we have to convert from zonal meridional to wind speed. So this is just a function, and just make some definition about that. Okay, and then we go to this section. Basically, this one is you will download the ERA 5 data from 1998 to 2020 over the D1 domain. Yeah, but if you have downloaded the data here, if you go here, the download dataset, you will have something like this. And if you have finished these 3 files, you don't have to download this part, because this code basically to check if there is no file like this, they will download. But if you already have, you just have this code will just extract and plot some figures. So just run on this code, and you will have something like this. So in this part means that the blue one is the V component over the D1 region, and the orange one is basically the value at November, December, January, February, and March, because this is where the cold surge is happening. I think this is also been discussed by Diong before. So this is basically the NDGFM data, the orange one. Okay, so after you sorry, after you extracting this is the U component first. So after this, you extract the U component. This is the U component, and then this is the V component. Again, both are from the era 5 for the NDGF. And then you also download the mean sea level. And if you run this code, yeah, you will have like this. But in this part, you just take the NDGFM period over the 23 years. And the next part, this is the where we convert from the UV to wind speed, because you have to have a criteria that the normalized wind speed has to more than 0.5 standard deviation. And if you run this, you will see, oh, sorry, something, oh, I need to run this first. Yeah, V. Yeah. So this is the wind speed. The blue one is the original wind speed. The orange one is the normalized wind speed in November to March for the 23 years. Okay, and then from those information, we get the call search criteria. There is 4 conditions. And basically this code is calculate how many days in those NDGF over the 23 years that fulfill these 4 criteria. And you just have to run this code, and you will have something like this. And it is said that during the NDGFM from 1998 to 2002, there are 446 call surges days. And again, this value can be different. It depends on what kind of data set that you have and the resolution. Because in this part, I use the 2.5 degrees mean sea level data. So that's why I have like a maybe less call surges day. But if you have more high resolution data, it can be more than this. And then the distribution is like for December, for January, you have like 175 days. And then this is February.
Donaldi, sorry.
Yes.
Yeah, sorry, Donaldi, there is a question on the chat. Say, what are the thresholds you are talking about? What are the thresholds? The threshold, you're talking about threshold?
This one. So this is the call surges days based on criteria. So this is the threshold that I said that the U, yeah, the definition of the call surge. So it has to have this 4 condition to be considered as a call surge day. Okay, I'll just continue here. In here that you have February like 95 days of call surges. This is March, and this is for November, and this is for December. So you see that December and January is where you have more call surges, call surge days. Okay, now we have the index for call surge. Now we want to find the index or how many days of the MJO. Because we want to see the interaction as well as the where these events occur together. So in this part that we extract the MJO RMM indexes from the MJO2 files. And then for the MJO criteria, you just choose the phase 2 to 4, because this is where the MJO active over the maritime continent with the amplitude more than 1 or equal 1, which is a strong MJO. And then this is we considered as a MJO days. So this is some kind of conditions that need to be fulfilled by this criteria. And then if you run this part, yeah, you will find that during the November to March from 1998 to 2020, there is like 876 MJO days. Okay. And then we now try to investigate the impact of both cold surges and MJO during for the rainfall. And this is basically how you calculate the events where the MJO and cold surges even occur together, or only cold surge, no MJO, MJO, no cold surge. You can do some more analysis in this part, but I will just focus on the days that both has cold surge and MJO. Okay, and then here, this code is this is where you read the large data that I said before. So this is, you read the CMORP data, which is basically the precipitation data in this domain. I just put the Southeast Asia, the western part. So this one, you first extract the rainfall, and then you calculate the mean precipitation during NDGFM period over the 23 years data. And then you calculate the mean precipitation when the cold surges occurred. And you also mean of the precipitation when the MJO, active MJO days. And you also calculate the mean precipitation when both events occurred. So this is kind of like the code that I tried to make. You just have to run this. Yeah, this is 19. And then this is, you read the zonal component over the 23 years data over the Southeast, the western part of Southeast Asia. You just have to run this part. And this is 20, okay. And this is the V component, which is the meridional component of the wind. You run again. Okay. And then this part is when you calculate the wind speed. Yeah, because the data is in U and V, and then you have to calculate the wind speed. I just run this part. Okay. Now you have wait for this one. Yeah, this is the 21, and then this is yeah, 22. Okay, finish. Now the rest of the code is just the plotting part. So the first plotting part is basically we plot the mean precipitation, during the cold surge, and the bias between the cold surge days and the climatology. Okay. Now you can run this one. Yeah, it will take some time, and then the figures will be saved with the cs.png files. It takes maybe half minutes, and you will have the figures something like, oh, it's finished already. And okay, it's okay. Sometimes you can just open this one, and then yeah, this is the CS PNG. Just a second ago, you can just click in this one. So this is the figures that you will have. That this is the mean precipitation of this 4-5 months. This is the wind speed, right? And this is the legend color. And then the second row is basically the mean precipitation during the cold surges days. And this is during the wind speed. So we can see the cold surge happen in this part. So you can see you will have higher wind speed over this area. the red color, and it's associated with the rainfall increase in some part of Southeast Asia, like here over Philippines. You will have less precipitation, and then it's getting higher here, and then northern part of Borneo, Malaysia, and Java Sea, even over the Makassar, close to Makassar. And then the third row is basically the anomaly of precipitation. So it's basically the second row minus the first row. So this is the anomaly of the when the cold surge event. So we'll see there is a positive anomaly of rainfall in the South China Sea, close to Kalimantan, Malacca Strait, and Java Sea, even close to Makassar. And for the wind speed, you can see also the red one, which is intensification of the wind speed over this area. And even there is also some negative wind speed anomaly over this area. Okay, now we go back to the next code. Next code is basically to see the impact of MJO here. Again, same, you can just run this part, and you will see yeah, something like this. Basically, this is maybe similar to the code that has been given in the first day by Fadil, I think, but this is just for all November to March data. Again, this is the climatology during this period, and this is during MJO days. So you can see there is some part that has a positive anomaly. This area is getting blue, right here, even in Sumatra, but particularly over the ocean. Yeah, over the ocean. For the wind speed, it's not so much different. And then if you see the bias here, yeah, this is the where you have a positive anomaly during the MJO days. In this case is phase 2, phase 3, and phase 4. And for the wind speed, not so much difference, even there is some negative wind anomaly in Java Sea, positive one over the Philippines area. Okay, and the last one is where we plot the impact both the cold surges and the MJO days. And if you run this part, you will have, again, this is the climatology, and this is the mean when the cold surges and the MJO active occurred. So we can see some area are very blue compared to the climatology. And for the wind speed, we can also still see the characteristic of the cold surge that you have intensified wind over the South China Sea. And if you calculate the bias, you can see that the impact is greater in some part in terms of rainfall anomaly, positive anomaly, and overall there is increasing wind speed over the northern part of Borneo and Indochina area. I think that's all my my talk about this practical session. This is just some references that you may see. All of these are discussing about the cold surges, MJO, and this is the latest publication by Lubis discussing about the chance can boost the MJO southward detour over the maritime continent. And I think for the thought, interactions cold surge with Rossby wave has been discussed by Diong, I think, and Kelvin wave also, and mixed Rossby gravity wave also been discussed. Maybe we can use that kind of information to see the impact of this interaction between cold surge and the equatorial waves. So again, thank you for your attention, and I'm happy to take questions. back to Thierry.
Thank you, Donaldi. Thank you very much. So are there questions about this? It's always, it's very useful for early career scientists to have examples of indices and for the forecasters to understand how it is constructed also. I don't see any question on the chapter. No? Okay. So thank you very much again. That's the end of the presentations. And
Thank you.
Now, thank you very much. Thank you, Donaldi. Now we have a bit of time for some discussion to summarize what has been said and discuss about a possible recommendation. Because I've got the microphone, I will keep it, and I forgot during my briefing to show you what I had done about. Sorry, an example of where is it? No, that's not this one. I'm trying to find my document. Is it this one? Oops, it's not the good one. Oops, I had prepared, but I lost it. Oh yeah, here it is. Yeah, I want, this is a document, this is an attempt, a try to write down what we had seen from the waves and their impact on the current situation. So this is a really first example of what could be done if the forecaster had the time to write a technical guidance discussion, about the current situation. And so I read, but I show you very fast. So the equatorial Rossby has been a major actor these days in providing vorticity and moisture. A complex MGO Kelvin event is imminent, is coming very fast. It will eventually break down the dry influence of El Nino and the positive IOD during 1 or 2 weeks. Nevertheless, it is not strong enough to bring very active conditions at a large scale. So it will give some kind neutral or slightly active, but not very active because the low frequency is still there. So the low frequency is predicted to remain in place after the passage of the MGO, so that the Indonesian-Australian monsoon onset is not ready yet. So we said that it was probably not the onset of the monsoon with this MGO, because we saw that the model still predicts some easterly anomaly after that. So in summarizing the risk of extremes for day 1 to day 3, which is the most important, extreme, EPE means extreme precipitation event possible day 2, day 3 over the Malaysian Peninsula and Southeast Island in a strong moisture convergence synoptic. It's a synoptic event, you know, in the cyclonic circulation, which is embedded in the equatorial Rossby vorticity. And at a lesser extent, so not as strong, in the Kalimata Strait, at day 1, day 2, there is some significant rain and because of the convergence. So it's a low possibility of extreme over there. And then for the outlook, extreme precip event possible over North Malaysia and Southeast Thailand. This is mainly based on because I did it quite quickly, based on the extreme forecast index. And the risk is very limited elsewhere in the maritime continent, which is it's a good news. And as for the risk of tessogenesis, it's also null or very low risk. It's well below climatology for the Philippines. So, and then there is a very technical description, which is to explain why what's in the summary. So we said rapidly, so the RMM index seems to indicate a clear robust signal, but things are more complex, etc., etc. I put the charts from Fadlil, and then I put in red the important things like there is a positive anomaly of upper divergence in the spreading over the maritime continent early next week. There is a wet contribution from Aceh to the South China Sea That's in the MGO, and then the influence of the Kelvin, of the equatorial Rossby, and the MRG. I will not read everything, but this will be available through beatas and in the coming days. Okay, and then in order to finish, this is an example of. Oh, sorry, I'm not sharing my screen. Huh? Oh, you should tell me, because you should tell me. In the room they see, but not online, sorry. Whoops, nobody told me. Poor of me. Okay, let me share my screen just for yeah, and then I have the discussion. I'm sorry. Yeah, so this is an example of what could be a graphical summary. It's not the current situation, it's an archive, but it's time consuming. But for a training, on a training purpose, for example, for the training, this is a good exercise to summarize graphically the drivers. So the colors are the colors that we use traditionally. The purple is this is French. BF is low frequency, and then the Kelvin and the symmetric vortices of the equatorial Rossbys. This is an example of what could be done, mostly as an exercise. It's very time consuming, but it's good to synthesize the comprehension of the forecaster. This is for analysis on top and prediction for week 1 or week 2, well, next week, but below. And the colors, the black is MGO, etc., etc. Okay? So this is just for discussion. So now I'm showing a document prepared by Beata. Beata is maybe still online. Beata has the idea of preparing a report, a written report of the workshop. So we will ask the speakers to provide some more ideas. This is a draft, and then we will ask you if you have no more ideas to add. So there will be a report about the importance of the introduction, the importance of understanding the waves. The current challenge is that there is a need of training to improve the expertise of the forecaster if we want human forecasting. Of course, there are also very good products based on statistical model output statistics about not the waves but the subseasonal models. But we are here more talking about short and medium range, about the equatorial waves. The MGO is more subseasonal, right? And we are now, which is more new, which is the equatorial waves for short and medium range. The MGO is still there is a bit more practice and also more numerical products with the MGO on the subseasonal scale. So what we saw during this workshop was a kind of review of the state of the art each day for one kind of wave each day. So it was a workshop. The aim was to make available to the forecasters the state of the art of the scientists, I would say, research scientists. Then about bridging theory and application, what are the key methodologies and tools that could be used by the forecasters? This will have to be described a bit longer. Then a guide for operational forecaster. I'm supposed to write it, Beata? Wow. How to? A practical guide regarding equatorial waves. I will ask help from colleagues. And then recommendation for future research and forecasting. So in blue, that's I will not read everything, but in blue, it's the important features. So facilitate regular discussions, dialogue, initiate reading clubs with forecasting teams. That's where we take some time to understand the important information from a scientific publication, for example. Then support plain language summary talks by scientists. You know, in the publications now, there is a summary and there is a plain text summary, which is more easy to understand for the non-professionals. We could have such talks, encourage scientists, meteorologists, and climate researchers to observe weather charts and attend open weather briefings together, foster a practical understanding of the real world forecasting. So scientists approach the forecasters and forecasters approach the scientists. And among forecasters, foster a culture of continuous learning and knowledge exchange. And important, advocate for financial support to facilitate the transition of scientific findings to operational forecasting. This must be, there must be funding, special funding for this subject. This is interesting, yeah. So organize conferences, meetings, workshops, test beds, which are also with users. So the test beds are scientists, forecasters, and users together. And then especially for the extreme precipitation events, encourage tropical forecasters to consistently observe all waves related to their specific area and season. Provide training and resources to forecasters to effectively use the visualization tools, and then conclusions. So this will be general recommendations. Some of them may be adopted by WMO, for example, but this is aimed at everybody. So that's all for me. Now it's up to you if you have new feedback, warm feedback, and some ideas for this future report document about the workshop. So in the room and online, I'm checking the chat. Okay, I start with the chat. Okay, development of hybrid model with dynamical, statistical, and artificial intelligence, machine learning will be something we can look at. Yes, there has been some publications on statistical, dynamical scores. For example, I know about the MJO. One of my colleagues, Damien Speck, wrote an article about this. And we heard this during this workshop about this mixed hybrid dynamical statistical methodology. Yes. Then using fine mesh model, convection permitting model like the WRF to enhance the skill with the filtered anomalies. Yes, I think there were some also case studies in the publications about using a large domain fine mesh model, but it's true that all the scales must be well resolved in order to resolve the upper scale, larger scales. In the room, here, do you have ideas that we can add? And in the following days, you can send, of course, by email. When you have ideas, suggestions, you can send to Beata Latos your ideas, which will be included in the report. It's very important. Why not include real-time presence of mesoscale convective system on tropical waves site on MISVA? Okay, I keep this proposal for Philippe Perrier. We can see that the websites we are using, some of the websites are maintained on an operational basis, maybe in the frame of WMO regional severe weather centers with meteograms and models and so on. But some other websites like Carl Schrepp's website, Philippe website, they are not maintained as operational. So the forecasters, they need an operational website to be, they want to be sure that they have the map every day. And this is something to be discussed also, to have, it requires foundings and people behind the website. And if the people get another job in another place, then the website must still be here. So this is also a request if we want operational products. Maybe we didn't summarize enough. Is it worth taking all this time looking at the waves? That was a question at the beginning. I don't know if you make your mind about that. My first impression is that it really helps to make the movie of the weather types. The movie, dry spell, wet spell, dry spell. It helps you when you see anomalies, blue, orange, green. It helps you to remove the noise that you see on a deterministic model or even ensemble model. You will see some spots of rain everywhere, every day. And just by looking at these charts, it helps you to build the movie of the prediction. I don't know if you agree with me, but for me, it's really, really obvious. So even if the models are perfect, it helps you to follow objects and have simple view scenario of the future. Okay, I don't see any more comment. So if there is no more comment, so this document will be improved in the coming weeks after a bit of rest from ourselves, and the speakers can add all they want, and then we will present maybe this kind of a document to review, like weather and forecasting. Okay, so Beata and I would like to thank all the speakers, the scientists who volunteered for this workshop. The local organization committee with all the technical stuff behind to be sure that it works well. We were in a great room with very good technical staff, and the BMKG for hosting this, for inviting the regional forecasters. Some of them come from rather far away by plane, several hours by plane from different islands. So I think they were happy to gather in Jakarta for 1 week. Will you come back? Will you come again? Yes? Okay, they said yes. We were happy to have forecasters from the Papua New Guinea, for example, and some other in India and Southeast Asia, and also early career scientists. It was a great gathering of both forecasters and scientists, because usually in the conferences, international conferences, there are many research scientists, but very few forecasters. And this time we were mixed. So altogether, we are going to give a big thank you to Beata Latos, who organized this meeting by herself from the beginning. She had the idea of this, and she created the website. She invited the people, and I don't know if she's online now, but I think she deserves a big applause from everybody online and in the room and outside. So applause for Beata. Okay. Yeah, thank you, Beata. And recover. We hope you will recover as fast as possible. and that it will be just a bad moment. Okay, thank you everybody, and keep in touch through Beata Lato's website, email, mine, and the ones from the scientist, and maybe prepare for another workshop another time. Thank you. Terima kasih.
Thank you, Thierry.